Welcome to the digital world of blockchain, where trust is established through code and cryptography. But what exactly is blockchain and how does it work? Let's dive in and find out. Let's start with the basics. At its core, a blockchain is a digital ledger that records transactions across a network of computers. It's like a digital version of a traditional ledger, but with a few key differences. Each block in a blockchain contains a batch of recent transactions. And when a new block is added to the chain, it becomes a permanent part of the network. This creates a chain of blocks, hence the name called blockchain. But how the blocks link with each other? Here the concept of hash comes. A hash is used to link the blocks together in the chain. Each block in the blockchain contains a set of transactions, and a hash of the previous block. This creates a secure, tamper-proof chain of blocks that contains a record of all the transactions. The process of generating a hash is called hashing. It involves taking a set of data, such as a block of transactions, and running it through a mathematical algorithm. The algorithm takes the data and produces a fixed-size string of characters, which is the hash. But what makes a blockchain so special and secure? Once a block is added to the chain, it cannot be altered. This creates a tamper-proof and secure record of all transactions, ensuring that data integrity is maintained. It's important to note that even the slightest change in the data will result in a completely different hash. This makes it extremely difficult for anyone to alter the data within a block without being detected. But how do all the blocks stay in sync across the network? That's where the consensus mechanism comes in. This is the system that allows all the members of a network to agree on the current state of the ledger. Different blockchain networks use different consensus mechanisms, such as proof of work or proof of stake. Let's take an example of a group of friends planning a trip. In the past, organizing a trip would have required a central organizer to collect money, book flights, and make other arrangements. But with blockchain, the group can use a consensus mechanism to agree on all the details of the trip without a central organizer. Imagine that each friend creates a transaction in the blockchain, outlining their preferences for the trip. These transactions are grouped together into a block and added to the chain of blocks. To add a block to the chain, the group must come to a consensus on the details of the trip. The most common consensus mechanism used in blockchain is called proof of work. In proof of work, the friends must mine the block by solving a complex mathematical problem. The first friend to solve the problem gets to add the block to the chain, and the rest of the group verifies the solution. Another consensus mechanism is called proof of stake. In proof of stake, instead of mining the block, the group members must stake their contribution. The member who has contributed the most gets to add the block to the chain. This way, the group can ensure that the person who is adding the block to the chain has a vested interest in the trip and is more likely to make responsible decisions. In this example, the consensus mechanism allows the group of friends to come to a decision about the trip without a central organizer. This is the same way that consensus mechanisms work in blockchain, allowing a decentralized network to agree on the state of the ledger. So you see, it's not just about planning a trip with friends, but it's about how a decentralized network can come to a consensus on any matter without the need of central authority. So, who adds these blocks to the chain? That's where miners come in. Miners play a crucial role in the blockchain ecosystem by validating and adding new transactions to the blockchain. In a proof-of-work consensus mechanism, miners use their computational power to solve complex mathematical problems, also known as mining puzzles or hashes. The first miner to solve the puzzle gets to add the next block to the blockchain and earn a reward in the form of cryptocurrency. This process of solving the puzzle is called mining, and it helps to ensure that transactions on the blockchain are secure and tamper-proof. The complexity of the mining puzzle is adjusted to maintain a consistent rate of block production, typically around 1 block per 10 minutes. On the other hand, in proof-of-stake consensus mechanism, instead of solving computational puzzles, the miner is chosen based on their stake, or the amount of cryptocurrency they hold and are willing to freeze or lock up to act as a miner. The more cryptocurrency a miner holds and locks up, the more likely they are to be chosen to create a block. This eliminates the need for miners to invest in expensive equipment to mine and reduces the energy consumption, That's why it's considered more energy efficient. It's like a digital lottery: the more tickets you have, the more chances you have of winning. This way, instead of using computational power, it uses the miner's economic stake in the cryptocurrency as a means to secure the network. And it also ensures that the miner has a vested interest in the success of the blockchain. Think mining process like a digital scavenger hunt, where miners are searching for the correct code or hash that will connect the next block in the chain. Once the correct hash is found, the block is added to the blockchain, and the miner is rewarded with a cryptocurrency for their efforts. But why do we need miners? The answer lies in the decentralized nature of blockchain technology. Without miners, there would be no way to ensure the integrity of the blockchain, and no way to prevent malicious actors from tampering with the ledger. Miners act as the gatekeepers of the blockchain, ensuring that only valid transactions are added to the chain. It's like having a group of security guards constantly monitoring a building, making sure only authorized personnel can enter, and that everything stays safe and secure.